welcome to another set of video notes. We're going to go ahead and move on to the next lesson, which is 3.7, and it's called Evaluate Determinants and Apply Cramer's Rule. We're going to split this up into two different videos. I don't know how I'll assign it, whether I'll have you watch everything at once or break it down. We'll just see. But today we're going to focus on the determinant part. So what a determinant is it's just a number that's related to that matrix, okay? And the way you find a determinant depends on the size. If you have a 2 by 2 determinant, what you're going to do is you are going to write it either way, up to you, okay? If you notice, it's exactly, everything's in the same spot, all right? But now instead of that big box thing, we just have what looks like absolute value. And when you see that around 4 numbers, you know we're talking about determinant. So it's the same thing. And what you do is you work on the diagonals. You say A times D, and then the other diagonal is between B and C. And then, just to really give you like all these pretty colors since I have them right now, you subtract between them. Okay? So, not a whole big deal, multiplying 4 numbers and subtracting. That's not too bad. Let's go ahead and look at an example. We are going to kind of move you around a little more today, but you'll be okay. Here we have a 2 by 2 matrix, so we get to just do that regular easy thing. We're going to write it again, 3, -2, 6, and 1. We've got it like that, and now we're just going to do the multiplying. So we multiply here. This diagonal is 3 times 1. Just to mess with you in the colors. This diagonal is 6 times -2. You need to go ahead and multiply those, and you get 3, and you get -12. And remember, we're going to subtract between them. So what is 3 minus a -12? It's actually 15. So the determinant for this matrix is 15. It's a number that's going to correspond and help us do some things that are pretty cool. Okay, well, let's go on to the bigger size. This is a 3 by 3 determinant, and just like it's a bigger matrix, it's going to be a bigger process to do, but we can still do it. Remember, you're going to draw those straight lines. You are going to write down ABC and all the entries again, and you've got G, H, I. Now, if you close it off, you'll notice, gosh, there's hardly any diagonals to do, so this is where we rewrite the first 2 columns. Remember, columns go up and down, okay? And now we're ready to find the diagonals. I think I'm going to do green and red to just kind of remind us of Christmas, no, to get through this. So first diagonal, you're going to do A times E times I. Okay, we need to do another diagonal, B times F times G. And the last diagonal we can go that goes this direction is C times D times H. Now, those are all going the same direction, so what you need to do between them is add them all together, okay? Now, above, when we did a 2 by 2, you went in both directions. So we're going to do the same thing now. We're going to go up this way, and we've got G times E times C. We also have H times F times A. And going up again, I, D, and B. So I times D times B. Now, just like before, we're going to add between them. They're all going the same direction. And what did we do between the 2 directions? We subtracted. Well, that's what we're going to do again. We're going to subtract between these 2 numbers. Okay? Let's go and try a 3 by 3. It's not horrible, especially if I give you smaller numbers and throw in some zeros. So let's go ahead and do this. We rewrite the matrix for -1, 2, -3, -2, -1, 0, 5, 1. You're also going to rewrite the first 2 columns. So we've got 4, -3, 0. The next one is -1, -2, 5. Now, if sometimes you write your stuff really close together and sometimes you really spread it out, you're going to want to try to stay consistent because it helps you see the diagonals better. Okay? So here we go. We'll go down. So we've got let's do it over here. 4 times negative 2 times 1. And then we're going to take negative 1 times negative 1 times 0. And we're going to take 2 times negative 3 times 5. Okay? Well, all these things I'm going to add up between them. So let's see. 4 times negative 2 times 1 is negative 8. That's just 0. Always nice. 2 times negative 3 times 5 is negative 30. So, what is negative 8 plus 0 plus negative 30? It's negative 38. Okay? A little more work, but still, this is not difficult to do. Let's go ahead and we'll use red for the other direction. We've got 0 times negative 2 times 2. We also have 5 times negative 1 times 4. Sorry about that. And then you've got 1 times negative 3 times negative 1. Okay? Well, and we know that eventually we'll add between those, but this one, what do we get? We get 0. Here we get negative 20, and here we get 3. So what is negative 20 plus 3? Well, that's negative 17, right? And now we just need to finish up. Negative 38 minus the negative 17, that's like adding, and you get negative 21, and that's your special number that goes along with this determinant, or with this matrix. Okay, now you might say, really, why would I care? Well, let me show you one place that makes it easy, and then in the next video you're really going to see how cool this is. So we're going to look and see how using a determinant will help you find the area of a triangle. Now for all of you that had geometry last year, you're all going, ooh, 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 I know how to find the area of a triangle. It's 1/2 base times height. Well, like on an ACT and stuff, they don't always give you what the height and the base are. They might just give you the coordinates of the vertices of that triangle, and you suddenly go, I'm going to have to do the distance formula and figure out the length of the perpendicular, and that sounds like a lot of work. Do it the shortcut. If you notice the formula, we still have 1/2. We have a 3 by 3 using the vertices and just a column of 1s. And then we notice we've got this funky plus and minus. If you think back, area has to be what? You're right, area has to be positive. So what it's saying is do whatever to make it positive. Either take the opposite or take what you've got, okay? So, you know how to work with a determinant. We're going to go ahead and do that. And in fact, we're just going to go to this example, okay? So, here are my coordinates for my vertices. So 1, 5, 1, 4, 6, 1, 7, 3, 1. Okay? That would be what we're working with, okay, or our 3 by 3. And we know that we just need to repeat those first 2 columns. Now, we're going to go through, and we're going to, I think the red is bright enough. I'm a little worried about the green. So I'm just going to draw through with red the whole time. So let's find our diagonals. 1 times 6 times 1, 5 times 1 times 7, and 1 times 4 times 3. So we get 6 plus 35 plus 12, and that is 41, 51, 53. Okay, but we're not done. We still need to do the other direction. I'm going to keep using this. So we've got 7 times 6 times 1, 3 times 1 times 1, and 1 times 4 times 5. So what does this give us? This gives us 42 plus 3 plus 20, which, let's see, altogether that's 65. Okay, so we come over here and we know that you are going to subtract between those big giant numbers, or at least those numbers that we did a lot to find. So 53 minus 65 is negative 12. And then don't forget what's in front of this, that plus minus 1/2. So we're still going to take 1/2 of this, which is negative 6. Now can you have a negative for area? Nope, so this is where you just get to take the opposite and say it's 6 square units. And that's it, and you just found the area of a triangle. Okay, pretty easy? I'll see you in class and we'll practice this. Bye.